Here we go working on the solution to the second truss problem. The second truss problem might be the hardest one of the three. Start where we started last one. Find the roller. Recognize that the roller can only push up. And then from there, we're going to find the pin and recognize that the pin can only stop it from spinning in either direction. So we're going to have a force up here, RA in the Y direction. Over here at the pin, we're going to have RCX and RCY. Those arrows may be wrong. We'll find out more as we work ourselves through this problem. First thing we want to do is recognize that the pin is where the rotation can happen around the pin. And we're going to try to make sure there's no rotation by making sure all the forces cancel out with their equal moments. So the sum of the moments must all add up to 0. And the 1,000 Newton force that we see first, that's going to create a positive moment, and it's working. So an up-down force, it's 3 meters away. There's a 500 Newton force that also makes it want to spin in the same direction, which is counterclockwise. 500 Newton force, that's operating, that's a left-right force, 4 meters away. And then there's the mystery one, the last one we don't know, to stop this from happening is RAY. It has to be a negative rotation that needs to create, so negative RAY times the fact that it's 6 meters away. So when we get this, we're going to get 0 equals 3,000 plus 2,000 equals plus negative RAY times 6. Negative RAY times 6 equals negative 5,000. RAY comes in at 833 newtons of force. And we have one reaction force figured out at this point. Now we go a little bit easier. Some of the forces in the Y direction, up and down forces, must all add up to 0. Right away in the problem we saw a negative 1,000 Newton force. So we'll establish that right away. In the beginning that was the only up-down force. We now know there's also RAY, which is plus 833 newtons. And there's also whatever RCY is going to do. So in comes RCY. So we have 1,000 down, we have 833 up. We need a little bit more upward force. So what's left over is what RCY needs to do. RCY needs to come in with 167 newtons, which is an upward force. Keep in mind there's 1,000 newtons down, there's 833 newtons pushing up here, and then if we have another 167 newtons up, that'll give us an upward force of 1,000 newtons, canceling out the 1,000 newtons down. Last part is the sum of the forces in the x direction must all add up to 0. Right in the very beginning we had 500 newtons right away, right in the beginning, plus whatever RCX is going to be given us, and that equals 0. So RCX comes in at negative 500 newtons. What we've done is we've gotten the vertical component of 1,000 newtons total between the two reaction forces to equal the 1,000 newtons applied to point B, and we've gotten reaction at C in the Y X direction to cancel out the 500 newtons to the right by coming back and pushing with 500 newtons to the left.